Okay, let's now look at question 5, which is the start of the functions questions. Okay, so question 5 says, given f of x is equal to 4 over x minus 3 plus 2 and g of x equals to x plus 2, write down the equations of the asymptote of f. Okay, so what are asymptotes? Remember, asymptotes are basically lines that your graph will get really close to. It'll approach, but it won't touch. Okay, so let's look at this here. So for hyperbolic graphs, which f of x is, there's a vertical and there's a horizontal asymptote. Okay, so the vertical asymptote is going to be x equals to 3. Okay, and then the horizontal will be y equals to 2. Okay, and we'll see how that works when we sketch the graph here in 5.4. Okay, but for now, just know that you take this becomes the y asymptote, and then this becomes the x asymptote. So you take whatever that is and you negate it. So if it is plus 3, it will become minus 3. Okay, let's look at 5.2 now. So 5.2 says, determine the x-intercept of f. Okay, so remember, x-intercept y equals to 0. Okay, so let's just equate this whole thing to 0. So 4 over x minus 3 plus 2. Okay, we just take in the equation of f of x. Okay, now we can just solve for x. So I'll bring this to the other side. So I'll have minus 2. And now I'll multiply everything by x minus 3. X minus 3 equals to 4. Okay, so I basically just brought that to that side. Multiply this through everything so that it becomes 4 on its own. Okay, let's multiply out of these brackets. So minus 2x plus 6 equals to 4. I'll bring this to that side. So 4 minus 6. 4 minus 6 is minus 2. And then therefore x is equal to 1. Okay. So that's the x-intercepts of x. So it's the actual coordinates are 1 and 0. Okay. 5.3, determine the y-intercept of f. Okay, so 5.3, now it's the opposite. So y-intercept x equals to 0. Okay, so y equals to 4 over x, and now instead of x I'm going to put 0 minus 3 plus 2. Okay, so this just becomes 4 negative 4 over 3 plus 2. I'm going to put that in my calculator. Negative 4 over 3 plus 2, that gives us 2 over 3. Okay, so then the actual coordinate is 0 and 2 over 3. Okay, let's look at 5.4 now. It says sketch the graphs of f and g on the same system of axes. Show clearly all the intercepts with the axes and any asymptotes. Okay, so let's first draw our set of axes. Okay, there's that. And now the next thing to do is the asymptotes. Okay, so we have our equations of our asymptotes over here. So we'll just draw that in now. I'll use blue. And so y equals 2. So here's y equals 2. It's going to be somewhere above the x-axis. And then x equals to 3. So x equals 3 is going to be somewhere on the right, or the left, sorry. On the right of the y-axis. Okay, so that will be there. Okay, and now we can just sketch in our graph. So let's draw in f of x in red, and remember f of x is our hyperbolic graph. Now there's a few things to take note of. Okay, so we took care of the asymptotes, right? Now we need to take care of the shape. So the general equation for a hyperbolic graph is y equals to a over x minus b plus q, right? Now we've dealt with this q and p, right? That's the asymptotes. Okay, Let's talk about this A now. So when A is positive, right, when A is positive, like in this case here, then our hyperbolic graph lies in the first and third quadrants, okay? And when A is negative, it lies in the second and fourth, okay? So keep that in mind, and now let's look at this one here. So in this case, A is positive, right? It's +4, okay? So that means our graph is going to be in the first and third, okay? So let's draw that in now. And remember, they won't touch the asymptote, so we'll use these blue lines that we drew as guides, okay? So let's just extend this a bit, okay? And now the first quadrant is here, right? So now it will move up to here, basically, okay? So let's put that in. And the third quadrant, so down here, okay? Let's draw it a bit neater. And you can see that it's not touching those asymptote lines, okay? Now let's put in these intercepts that we had. So the x-intercept was at 1 and 0. So the x-intercept is at 1 and 0. And our y-intercept was at 0 and 2/3. So 0 and 2/3. Okay, so that takes care of f of x. Okay, now let's do g of x. So I'll do that in red. G of x is just a straight line, x plus 2, y equals x plus 2. Okay, so what does that mean? That means that we had a straight line and then it got shifted up by 2 units. Okay, so we started off here with y equals x and it moved up by 2 units. So let's do that. So we'll take the straight line and just move it up to 2 units. Okay. Now, another thing that you should keep in mind is you might just label these asymptotes. So this was y equals 2, and this one was x equals 3. Okay, and let's put in this point here as well for the y-intercept of this. It's just 0 and 2. Okay, and how did I get 2? Because that's the shift there. Okay. Okay, so now that we have this drawn, I think that's all the information they asked for. They asked for the intercepts, which we've shown, and the asymptotes. Okay. Let's now look at the next question. 5.5. Calculate the x coordinates of the points of intersection of f and g. Okay, so you can see we have 2 points of intersection. So let's find what those x values are. So the way to do that is just to take f of x and equate it to g of x. Okay, so let's do that. 5.5 f of x equals to g of x, right? So we have 4 over x minus 3 plus 2. 4 over x minus 3 plus 2 equals to x plus 2. Okay, x plus 2. Now if you look at these plus 2's, if I bring this to this side, it's going to become minus 2. So it'll just cancel each other out. So I can get rid of those already. Okay. And then now I can get rid of this fraction by multiplying it. So this will become x times x minus 3. Right, you can see I brought this from here to there. Okay, so 4 equals x squared minus 3x. And now I'll just bring this 4 to this side. So this will become minus 4. And this will become 0. Okay, and now you can see we just have a quadratic equation to solve, and that makes sense. We'll have two x values because we have 2 points of intersection. Okay, so let's quickly solve that. Now remember, to solve this trinomial, to factorize it, we need to find two numbers that when I add them together I get minus 3, and when I multiply them together I get minus 4. So let's see what those two numbers are going to be. Okay, let's try minus 4x plus x. Okay, so this is the same as saying plus 1x minus 4. Let's see if that works. So if I take minus 4 plus 1, I get minus 3. If I take minus 4 times 1, I get minus 4. So that gives me my minus 3 when I add them together, and that gives me my minus 4 when I multiply them. Okay. Okay, cool. So now it's just a case of factorizing all this here. Okay, and remember this was equal to 0, this was equal to 0. Okay, now I can take out this common factor x minus 4. So x minus 4, x plus 1 equals 0. I can equate them both to 0, so I'll get x equals 4 or x equals to minus 1. Okay, so that's our final answers, and that's correct. Now let's go back to our graph and see if that makes sense. So here x equals minus 1. That makes sense, it's before the y-axis. And x equals to 4. And that makes sense for here. Because remember this line is minus 3. Oh, sorry, this line is 3. So that does make sense if that's 4. It's after that. Okay, cool. Okay, so that takes care of 5.5. Let's look at 5.6. If x is less than 3, determine the values of x for which 4 over x plus 2 is less than x plus 2. Okay, so if we look carefully now, 4 over x minus 3 plus 2 and x plus 2 is literally just f and g, right? Those are the same exact equations. Okay, so the question is basically asking, let's write this in a way that makes more sense. For which values of x, let's ignore this first part for now, let's just read this. For which values of x will f of x be less than g of x? Okay, so we can take our orders and just ask the question as it is, right? But now they're saying let's restrict that question to when x is less than 3. So if we come back to our graph here on top, we're talking about all the values less than 3. Okay, so there's x equals 3. So we're going to consider everything before that. Okay, because they want less than 3. So if we look at our graph here, right, they're asking for the values of x where f of x is less than g of x. Okay, so f of x is our parabola, and it is less than the straight line than g of x from this point onwards, right? You can see that if we start from here going in this direction, it's greater, right? You can see it's above the straight line. If we keep going, it's always above until that point of intersection, and from there till our asymptote, it's less than the straight line. So that's basically the area that we're looking for. Okay, so from here till there. And our x value here, remember, was minus 1. Okay, so our answer then will be, so for 5.6, our answer will be that x has to be greater than minus 1 but less than 3. Okay, see if that makes sense. So I'm going to highlight the part that we're talking about. We're talking about from here until the asymptote, right? And you can see from that point onwards, our straight line is actually greater than our hyperbolic graph. So that means that answer is correct. Okay, let's move on to the last question now. 5.7 says, the line y equals to x minus 1 cuts f, so that's our hyperbola, at P, which has the coordinates of 1 and 0, and Q. Write down the coordinates of Q. Okay, so let's think about this. The line y equals x minus 1. Okay, so here's a line y equals x. Okay, there's a cut in the origin, and then I moved it down by 1. Okay, so our question is, at what points do they intersect? So we told that it intersects at 1 and 0. Okay, so here's 1 and 0 actually already drawn on, which was the x-intercept. So this point is point P then, and then we have to find point Q. Okay, so let's do that. So again, we're just going to equate f of x to that line y equals x minus 1. So our equation for f of x was 4 over x minus 3 plus 2 equals to x minus 1. Okay, so let's get rid of this denominator by multiplying it out. So I'll have 4 plus 2 times x minus 3 equals to x times x minus 3 minus 1 times x minus 3. Okay, so I'll have 4 plus 2x minus 6 equals to x squared minus 3x minus x plus 3. Okay, let's put all our terms on one side and group them. So I'll have x squared. Now I'm going to bring this minus 2x to this side and then add all our terms with x. So minus 3 minus 1 minus 2. Okay, because I brought this minus 2 to that side. So that becomes minus 6x. And now I'll do the same with our terms without any variables. Okay, so I'll take this first 3 on this side. So 3 plus 6 minus 4 gives us plus 5 equals to 0. Okay, and now it's a case of just finding our factors and then solving. Okay, so again, we're going to look for two numbers that when I add them together, I get minus 6, and when I multiply them, I get plus 5. So x squared, let's try minus 5x minus x, right? Minus 1x, same thing, plus 5 equals 0. So if I take minus 5 minus 1, I get minus 6. If I take minus 5 times minus 1, I get 5. So there's our minus 6. Okay, and there's our plus 5. So that means that that works. Okay, so now that we have our factors, let's factorize. So I'll have x minus 5 minus 1 times x minus 5. Okay, I have common factor here, so I can factorize that out. X minus 5, x minus 1 equals 0. I'll equate them both to 0. I'll have x equals 5 or x equals to 1. Now, we can very easily confirm that this answer is right because x equals 1 and we were told that one of the points of intersection is when x equals 1. Okay, so that's obviously for the point P. That's for the point P. And then we have to find the point Q. So that means that the x value of Q is 5. Okay, so let's just take this out. And then we can say, therefore, x of Q is 5. Okay, and then we can just use that equation that they gave us, y equals x minus 1, to find the y value. Okay, so y equals to 5 minus 1. So that means that y equals to 4. Okay, let's write it down. 5 minus 1, and then therefore y equals to 4. Okay, so that means that the point Q is at 5 and at 4. Okay, now let's think if that makes sense. Okay, so we're saying that Q is at 5 and 4. Right, let's go back to our graph where we drew it in. Remember, this was the line y equals 2. So the fact that our point of intersection is above that there, right? We said this is at 5 and 4. Okay, so the fact that this is at 4 means that that looks fine because it's above that line. And the fact that this is 5 and this line here was 3 and it's on that side of the line means that that also makes sense. Okay, so that's question 5 done.